Video number 196, common graphs and their translations. Let's look at linear, y equals x. We're going to do this one sheet at a time here. Actually, we're just going to use the sheet and the calculator. Bam, here's the calculator. Let's go for it. Now, what I've done is I've thrown in all 5 of the graphs we're going to look at, but I don't notice how I only have the equal sign highlighted on the first graph. So therefore, that's the one that the graphing calculator will concentrate on graphing. So I'm going to press zoom 6 for zoom standard. There's the line y equals x. It's a 45-degree angle cutting the graph in half. Now, if we wanted to, let's go in here. Let's go to the second one, y equals x. Let's go x plus 3. And just to remind us which one's different, we're going to go to the left and press enter to make that a bold line. Notice the second one is above the first one by 3 units. So if you press trace, it puts us at 0, 0, go up, it goes up to 0, 3. Okay. Therefore, we could say that plus 3 increases the graph's y value. See, this says y values equal x. This says what? Y values are increased by 3. See how that works out? And of course, we could also press minus. Let's go minus 7. Graph. There's your original mother graph. Minus 7. Bam. Okay, so as we could see here, the plus and the minus move the graph up and down. Okay? Now, another thing that happens here for linears, now let's go ahead and let's get rid of this. Let's insert a 3 here. So now we got y equals 3x. So there's your y equals x. Bam, there's y equals 3x. Notice how 3x's slope is steeper. It's a steeper slope. The first graph, you're going to go up 5 and over 5. So every 5 days, it goes up $5. Here, every 5 days, it's going to go up $15. So the y values are being multiplied by 3. That's why it's a taller graph. Okay? Then, of course, what if the number in front of here was 0.3, so it was less than 1. Bam! There's your mother graph. Now look at this. Now the graph is less steep because the slope was a smaller amount. It was smaller than 1. So then now it's going to take you, if you go over 5, it'll be up whatever 30% of 5 is, right around, you know, a little less than 2. So, okay, so hopefully we understand that this value in front of x, if it's more than 1, it's going to be steeper than the original. If it's less than 1, it's going to be shorter than the original, okay, or wider, or less slope, less steep. Okay, let's move on. We've exhausted this. We're going to press enter on there, press enter on here. Let's go to the quadratic and press enter. Bam, there's the graph on the standard graph, y equals x squared. Okay, now what we could do is let's make our window a little bit different. Let's go up a little more. Let's go up to 25. See what happens. Give us a little bit better view. All right, now what we'll do is we're going to go to x squared and watch this. We're going to go ahead and just kind of recap something we already know. Let's go minus 7. Any guesses? Bam! It's going to be below the origin by 7. And there it is. Now, watch this one. Instead of minus 7, after we square x, let's delete. Let's go inside here. We're going to insert, we're going to go x minus 4. And we're going to put this in parentheses. Okay, so we're squaring the quantity x minus 4. Any guesses? Some people might think the graph's going to shift to the left or to the right. And let's take a look. A lot of people, and in fact myself, might guess it's going to go to the left 4, but ironically enough, there's the mother. It goes to the right 4. Not to the left, but to the right. And here's why. If we can just quickly run through the mathematics behind this. On the quadratic, 0, 0 was the vertex, and then 1, 1, and then 2, 4, right? And you get this curved shape. There's the mother graph of the quadratic. Now, if we were to go x minus 4 quantity squared as we've indicated, in order for us to find the vertex, we want to have a zero height. Well, not necessarily a zero height, but we want to have a 0x value. So in order to have a 0x value, excuse me, not a 0x value, but a zero that's being what? Squared, right? The reason this is the vertex here is because when you plug in 0 for x, you get a 0 that's being squared. Okay? So what's going to zero out the squared? A positive 4 zeroes out the squared, thus creating a 5 gives you a 1 squared, and a 3 gives you a negative 1 squared. So there's where you have your graph. So it's going to be an opposite situation. So for example, if we were to zoom in here, let's go ahead and change these numbers around a little bit. Where's the cursor? There it is. Okay. Oh, let's change this to a plus and change that to a 3. Now which way are we going? There's the mother graph. Now we're going left 3. Okay? So the parenthesis shifts the graph left and right. The number on the outside shifts it up and down. And just as we might suspect, watch this. Let's add another number here. Let's go plus 4, plus 3 on the inside, plus 4 on the outside. What's the guess? Guess in your head or yell it out. Bam, here it is. There's the mother graph. Left 3. And where is that probably? Up 4. In fact, watch this. Let's do a minimum. Oh, let's go to this graph. I had to press up to go to the second graph. So we're going to go left bound, yes. Right bound, yes. And we'll go to the middle here, negative 3, 4. All right, so there you go. Let's continue with this. We'll go ahead and press enter on that equal sign and minimize that so you can't see anymore. There's a cubic function, okay? And our cubic looks like this. Let's go zoom standard. All right, and what we can do is let's go a little taller. Let's go up to 20. Wait, I didn't mean to do it that. I want the y values. To increase negative up and down 20. There we go. Okay, now if we were to again, let's do a second graph here. Okay. Let's go inside here. Let's put a parentheses, insert. So we're going to do x minus 4, parentheses. We're going to delete that other x. Then we're going to go plus 9. Okay. There's the graph. Okay, now look what happened here. Okay. Now, guys, by the way, this point here at the origin on the original graph is referred to as what's called a point of inflection. That point of inflection moved for the second graph. It moved where? To the right 4 and up 9. Is that some kind of, not the right 4 and up 9, or is that right? That is right. It went to the right 4 and up 9. Why did that happen? Because